Hello everyone. I'm going to be talking about expected value. Okay, let's begin with a simple example. Imagine I throw a dice experiment and these are my outcomes. So the question that I'm going to be asking is, what is the expected outcome I will get? Now, I am not focusing on any specific outcome, but I'm asking in general, what is the expected outcome I will get in general? Okay, so if you were to relate to past topics, especially statistics, when we consider things in general, we always talk about averages. So the same thing here. When I ask for the expected outcome and I'm not focusing on any outcome in particular, okay, it means I'm focusing on all the outcomes in general and I am asking for the average. Okay, so how do I do that? So let's take a close look at our experiment. So imagine I were to do this experiment, okay, using a real dice. And let's say for example I were to do this 10 times. Okay, I do it over 10 throws. And let's imagine in this 10 throws I get 3 ones, I get 2 twos, I get 1 with outcome 3, I get 1 for outcome 4, for outcome 5 I get 2 times, and outcome 6 I get 1 time. Okay, so I throw the dice 10 times and the number of each outcome that I get is listed here. So what is a probability? Recall the definition of probability is the number of desired outcomes over total number of outcomes. So my probability for each outcome will be over 10. So I have 3 ones. So the probability of getting a 1 is 3 over 10. And I have 2 twos. So the probability is 2 over 10. Okay, for outcome 3, I only get ones. So the probability is 1 over 10. For outcome 4, I only get 1, so 1 over 10. So if you understand the logic, okay, and follow through, if you just follow as following. Okay, so that is how I got the probability. Okay, I do the experiment 10 times, I count how many times I got for each outcome, and then I create the probability table. Okay, this is a discrete random probability distribution. Okay, so I was trying to find the expected outcome of this experiment, and a while ago I said that expected outcome has the same meaning as the average. So what I'm looking for is actually the average outcome in these 10 throws. Okay, now let's look at this in another way, in something that we are familiar with in our frequency table. Look at the blue table. X represent the outcomes and the number of times that outcome happens. Okay, recall number of times is the same as frequency. So for outcome 1, I got 3 times, so it's like that. For outcome 2, I get 2 times, so it's like that. Outcome 3, I got 1, so it's like that. And you can follow the logic, it goes like this. Lastly, to get 6, I only get 1 time, so it's as follows. Okay, now recall, how do we calculate the mean, the average of this? Remember this formula, sum of fx over sum of f. Okay, let's apply it. First is 1 times 3. Okay, then 2 times 2, 3 times 1, 4 times 1, 5 times 2, and 6 times 1 over the sum of f. So over 3 plus 2 plus 1 plus 1 plus 2 plus 1. Okay, the denominator when you add up, it gives you 1. Okay, it gives you 10. Remember we had 10 throws. Okay, now I am going to do something. Okay, this is a combined fraction. Now I'm going to break them up into little fractions. So please watch carefully. I can write as this 1 times 3 over 10 plus another tiny fraction 2 times 2 over 10, 3 times 1 over 10, and the rest. Okay, take a moment to look at this. When I add all these little fractions, do I get back the big fraction on the second line? Yes, I do. Okay, when you have the same denominator, you just add the numerator. So I will get back the big fraction on the second line. Now, why did I do this? Why did I break them up into tiny fractions? Now, observe carefully. Okay, I'm going to break them up further. 1 times 3 over 10 is the same as 1 times the fraction 3 over 10. Is that correct? Okay, just use logic. Okay, I'm going to use the same thing on the others. 2 times the fraction 2 over 10, 3 times the fraction 1 over 10, and so on and so forth. Okay, so why did I do this? Okay, hold on. Why did I do this? If you look carefully, each of them is actually x times p. Okay, compare this with the table above. Isn't each of them the same as x times p? And thus we have come to the formula for expected value. Okay, expected value, the symbol is e x because we are finding the expected value of some random variable. Okay, there's another symbol for it. It looks like u, but it's called mu, M-I-U. And the formula from the previous slide, as you saw just now, is just add all the x times p. So this is the formula for expected value, which we have related it to average. Alright, so this is the proof of the formula for expected value.